Hi, I'm Joaquim from the University of Glasgow. In this talk I will present the core claims of a work-in-progress paper titled Fundamental Yet Grounded. Let me know, before we proceed any further, that the shape of the paper is slightly different from what the abstract suggests. Let us start with the notion of grounding. As I shall understand it, grounding is a non-causal determinative connection with explanatory import. We can say that if an entity A grounds an entity B, then B obtains because or in virtue of A. On the orthodox view, grounding has three structural properties. It is irreflexive, asymmetric, and transitive. Grounding has an intimate tie with the fundamental. On the orthodox view, we can define the absolutely fundamental in terms of ungroundedness, where an entity is ungrounded if nothing grounds it. Accordingly, as expressed by Full, an entity X is fundamental just in case X is ungrounded. It is worth noting that the orthodox view of grounding maintains also that we can regiment the relative sense of fundamentality in terms of grounding, as expressed by the principle GMFT, which states that if X grounds Y, then X is more fundamental than Y. Here, my focus will be on the absolute notions of fundamentality. For now, I will set the GMFT principle aside. What is the problem for a definition of the fundamental as the ungrounded? It has been recently argued that there can be fundamental and yet mutually grounded entities. Since this possibility threatens the orthodox view of grounding, let us call it the heresy. Here you have a more precise formulation. Controversial examples for fundamental mutually grounded entities include Leibnizian monads, quarks, and Yuan existence. In what follows, I will focus on the heresy as a metaphysical possibility, so I shall not evaluate these examples. Proponents of the heresy, for example Jessica Wilson and Thomas Taco, have argued that a definition of the fundamental as the ungrounded rules out the heresy inappropriately. But if we accept the metaphysical possibility of fundamentally mutually grounded entities, then a definition such as full is inadequate. Let us call this the inadequacy objection. An immediate question arises. Does the heresy force us to abandon the project of characterizing the fundamental in terms of grounding? I want to defend a negative answer. In this talk I will show how to reformulate full in a way that accommodates the possibility of fundamental mutually grounded entities. Then I will vindicate this approach by resisting two objections that Wilson raises against a similar framework suggested by Karen Bennett. Here's the plan. I shall start by laying out a few assumptions. After that, I will illustrate the revised version of full, and lastly, I outline how to resist Wilson's objections. To start, here are some important assumptions. First, I assume the truth of the heresy for the sake of argument. Second, it is important to acknowledge that Wilson defends several independent considerations against full and for the adoption of a primitivist conceptions of the fundamental. Here I shall not discuss the primitivist framework about the fundamental, so I will not assess these arguments. Third, I assume the coherence of the non-asymmetry of grounding. Unfortunately, I have no time to unpack this point, but feel free to ask me during the Q&A. Fourth, I shall remain neutral on the strength of the link between grounding and explanation, and similarly I shall remain neutral on the relata of grounding. Lastly, unless specified, I will focus on the full notion of grounding. Bearing this remark in mind, let us move on to illustrating how to reformulate full. My strategy is to embrace the possibility of non-asymmetric grounding and reformulate full accordingly. On the proposed view, it is possible that X and Y are such that X grounds Y and Y grounds X. Now, we need a definition of the fundamental that accommodates possible fundamental mutually grounded entities. To do so, we can draw from Bennett, who proposes but does not adopt the following definition in terms of independent star. Independent star says that something is fundamental just in case for all Y such that Y builds X, X builds Y. In a similar fashion, I submit that a definition of the fundamental as full star, which states that an entity X is fundamental just in case this conditional is true. For every entity Y, if Y grounds X, then X grounds Y. I shall illustrate the workings of full star in a moment. For now, let us note that both independent star and full star yield that X is fundamental if it is ungrounded. I am sure you noted the striking similarity between independent star and full star, so let me highlight a few important differences with the Bennettian framework. To start, Bennett does not endorse independent star. She says, for example, I do not endorse the claim that absolute fundamentality is independent star. I think it is independence, because I do not think anything is self-built or symmetrically built. By contrast, I accommodate the possibility of symmetric grounding. Relatedly, I do endorse full star as a more suitable definition of the fundamental. My approach has, therefore, two important consequences, which here I cannot explore because of time constraints. One is that I reject the GMT principle. Because of the possibility of a non-asymmetric grounding, I accept that it is not the case that if X grounds Y, then X is more fundamental than Y. Lastly, as a consequence of this strategy, is that grounding is not a building relation. Bennett, by contrast, characterizes building relations as being asymmetric, but as I said, I endorse the non-asymmetry of grounding. Now I turn to illustrate the mechanics of full stars. I will do so by considering two grounding structures. It will become clear if full stars captures the heresy, namely the possibility of fundamental mutually grounded entities. Here's the first case. Consider a possible world where there are only two entities, A and B, and these entities are symmetrically grounded. The diagram depicts these grounding structures. Now let us ask, are A and B fundamental in this case? To answer these questions, we run full stars for A and B respectively. Let us start with A. Since it is true that A grounds B and B grounds A, also the conditional in the right-hand side of full star is true. Namely, it is true that if B grounds A, then A grounds B. So it is true that A is fundamental. By parity of reasoning, B is also fundamental. The conditional, if A grounds B, then B grounds A, is true. In these structures, as the truth table illustrates, both A and B are fundamental. This is, therefore, a case where two entities are mutually grounded and yet fundamental. A few comments in order. The proposed definition of the fundamental accommodates the heresy, therefore it evades the charge of inadequacy. It does not rule out the possibility of fundamental mutually grounded entities. It is important to note, however, that if grounding is not asymmetric, then we must decide between two options. One is that grounding is irreflexive and not transitive. The other is that grounding is not irreflexive and transitive. Unfortunately, I cannot discuss which of these options we ought to favor. Feel free to ask me during the Q&A. For now, let me stress that full star is compatible with both. In what follows, however, I shall adopt the transitivity of grounding. Note that these options permits the possibility of fundamental self-grounded entities. Now let us consider another case. In this possible world, we have only three entities, A, B, and C. These entities form the ground instruction which is depicted by this diagram. A and B are mutually grounded, and C grounds A. That is, A is asymmetrically grounded in C. Now let us ask, is A fundamental in this case? Full star yields a negative answer. It is not the case that for every Y, if Y grounds A, then A grounds Y. More in detail, it is true that if B grounds A, then A grounds B. This is because A and B are mutually grounded. But it is not the case that if C grounds A, then A grounds C. In this structure, A does not ground C, so the conditional in the right-hand side of full star is false. What about B? Is it fundamental? The answer is again negative. It is not the case that for every Y, if Y grounds B, then B grounds A. In these structures, as the truth table shows, C grounds B transitively, but B does not ground C, so the conditional, if C grounds B, then B grounds C, is false. Lastly, let us consider C. Is this entity fundamental? The answer, this time, is positive. In this structure, it is true that for every Y, if Y grounds C, then C grounds Y. C grounds both A and B, but neither A nor B grounds C. Therefore, the corresponding conditional are true. To repeat on full star, an ungrounded entity is fundamental. Let me now summarize the key advantages of full star. First, it accommodates the possibility of non-asymmetric grounding between fundamental as well as non-fundamental entities. Second, and relatedly, it permits us to capture the heresy. The full star evades the inadequacy objection. Third, the proposed definition of the fundamental is compatible with other non-orthodox view about the formal features of grounding. It appears therefore that full star is a more suitable definition of the fundamental, one which is preferable to a definition in terms of ungroundedness. Unfortunately, full star is not exempt from difficulties. I now turn to outline and address two objections that Jessica Wilson raises against Bennett's independent star. Since these definitions and full stars are formally similar, Wilson's objections target full stars as well. Let us start with what I call the strong emergence objection. As Wilson puts it, independent stars and full stars won't accommodate the possibility of fundamentally strongly emergent goings-ons, which may be partly and asymmetrically constituted by fundamental physical goings-on. To illustrate, consider a strongly emergent entity A, which is asymmetrically grounded in some entity F. Full star yields that E, the emergent entity, is not fundamental. The strong emergence objection scores the points against full star. It is true that full stars cannot accommodate fundamental strongly emergent entities if these are asymmetrically grounded in some other entities. However, this is not to say that the advocate of full star has no room for strongly emergent entities at all. They can argue that the alleged fundamentality of strongly emergent entities is neither ungroundedness nor mutual groundedness. There are various ways of thinking of the fundamentality of strongly emergent entities. For example, we can think of it in terms of the causal novelty of the strongly emergent entity relative to the lower level entity upon which it depends on a certain occasion. This is a conception defended in various places by Wilson. In broad strokes, if we adopt this strategy, we could say that a strongly emergent entity is fundamental in the sense that it has at least one causal power, not identical with any powers of the lower level entity upon which it depends. The advocate of independent star can invoke a similar strategy. Therefore, there is a way to mitigate the strong emergence objection. Now, let us consider what I call the selection objection. Wilson claims that independent star and, by virtue of similarity, full star are inadequate because, since many mutually dependent goings-on are not fundamental, something besides building or its absence must be willed in to select dependence goings-on that are fundamental. As I understand it, the objection is that full star is incapable on its own to distinguish between fundamental and non-fundamental entities. Of course, this would be problematic, and it would be problematic if full star gives us that two mutually grounded entities, like A and B in this case, are always fundamental. However, on closer inspection, it seems to me that full stars evade the selection objection. To see why, we need to consider a consequence of full star. On this definition, an entity X is not fundamental if there is at least one entity Y such that X is asymmetrically grounded in Y. This is true for mutually grounded entities as well. Therefore, on full star, it is not the case that all mutually grounded entities are fundamental. The crucial point here is that the proposed definition does not need extra support to distinguish between fundamental and non-fundamental mutually grounded entities. Only the mutually grounded entities that satisfy full star are fundamental. It might be useful to illustrate the previous claim with an example. Let us consider this grounding structure. We have three mutually grounded entities, F and G, that are asymmetrically grounded in two further entities, R and S respectively. If the selection objection were sound, full star would not yield that F and G are not fundamental. But full star does deliver this result. Consider F first. It is not true that for every Y, if Y grounds F, then F grounds Y. F grounds neither R nor S, therefore F is not fundamental. And now let us consider G. Like F, this entity is not fundamental because it is not the case that for every Y, if Y grounds G, then G grounds Y. Also in this case, G grounds neither R nor S. Therefore, it seems the full star is capable of distinguishing between mutually grounded entities that are fundamental, as we've seen in the previous case, and mutually grounded entities that are not fundamental, like in this case. It is time to wrap up. Here are the main take-home points. Full star permits the possibility of fundamental and non-fundamental mutually grounded entities. Importantly, full star does not need to be supplemented with other resources to distinguish between fundamental and fundamental mutually grounded entities. Therefore, full star escapes the selection objection. Independent stars also evades the selection objection. You can test it by applying the definitions to the previous structure. However, recall that Bennett does not endorse independent star. Bennett, by contrast, endorses independence, which, like full, does not accommodate the possibility of fundamental mutually grounded or built entities, be them fundamental or not. And since full stars accommodates the possibilities, it is the most suitable characterizations of the fundamental, one which it evades the inadequacy objections. Of course, there's a lot more that could be said, so I look forward to reading your comments. Thank you for watching.